This will be number 2 in your notebook for the expressions and equations unit. What we're going to do this time in this notebook is number 2 in your notebook is going to be any notes take that I give you plus any notes that you take. That way all your notes will be in the same place. Now what we're going to start with now is something called order of operations, and order of operations is probably something that you've been familiar with since you were a little kid. But I want to give you a new spin on it here. What you may have been taught here was that there were 6 steps. Please excuse my dear Aunt Sally for parentheses, exponents, multiply, divide, add, and subtract. Well, what you need to remember, there are actually only 4 steps. We still do parentheses first, and then we still evaluate exponents second. But then we do multiply and division in order from left to right. Just like I'm writing here from left to right, we look at an equation or expression from left to right, and we do multiplication and division, whichever one comes first. Now keep in mind, parentheses is always going to come before exponents, and exponents is still always going to come before this, and this is always going to come before this. But when you get to number 3, multiplication and division, you go from left to right of whatever's next. So it is possible to do division before multiplication and subtraction before addition. Now please keep in mind, it is never good or never right to do these 2 before these 2. It's never good to do adding and subtracting before multiplication and division. Just remember, when you get to that on a problem, when you get to step 3, you do whichever one comes first. Keeping in mind that, again, we do parentheses and exponents before that. And then when we're done with that, we move on to addition and subtraction. And I'll show you an example right here. I've made a problem here that'll use that. Now what you need to do when you get one of these problems like I'm going to give you here, you need to rewrite it after every small step. I know it seems tedious, I know it seems like a pain, but you need to do it. That way you can keep track of everything that you've done so far. Some of the biggest problems I've seen on your tests and quizzes is that you start writing real small and you start doing stuff in your head. It doesn't take very much extra time at all to go ahead and do this. Okay. So we've got a problem. 4 times, inside the parentheses, 2 plus 6 minus 7 plus 4 squared. Okay. Well, again, let's take a look at the entire thing and ask ourselves, well, are there any parentheses? Well, I've got one right there. Now, if you have a longer, just a part of this expression inside parentheses, you'd go from left to right and perform the order of operations inside that parentheses if you had any other operations. In this case, we just had the 2 plus a 6, so we just go from there. So in this case, inside the parentheses, we have 2 plus 6. So what I want you to do is rewrite the whole thing like I've done. We got a 4. 2 plus 6 is 8, and I've brought that down here. Minus 7 plus 4 squared. Okay? Now, we start all over. Are there any parentheses? Well, no, those have all been taken care of. Then we do exponents. And remember, 4 raised to the 2nd power, that is not 4 times 2. That is 4 times itself. If it were 4 to the 3rd, it would be 4 times 4 times 4. Just don't forget what an exponent actually is. And we'll go over these terms more in just a second. But 4 squared is 16. So we rewrite everything. 4 times 8 minus 7 plus, instead of saying plus 4 squared, we say 16. Okay. Then again, we start the process over. Please excuse my dear Aunt Sally. Okay. We do. Now we're done with exponents. Now we can do multiplication and division. And remember, we would go from left to right here. Okay. If there were a division portion of this expression before, we'd do it first. But now we just have multiplication. We're going to start here and multiply that out. That'll be 32. Bring down your minus 7. Bring down your plus 16. Now we're left with this. Please excuse. Now, you might have been taught earlier that you always do addition before, but since subtraction is part of the same step, which is step 4, you're going to do it first because it comes first in the expression. 32 minus 7 is 25 plus 16. And again, rewrite it every time. And then, of course, 25 plus 16 is 41. So what you need to do is make sure you're going through the steps very slowly, and remember that you have 4 steps in the order of operations, not 6, like you've probably been taught since you were itty-bitty. And remember, you can do division before multiplication if it comes first in the problem. But remember, you can't do that before this. Remember, there are 4 steps to the order of operations, not 6. Okay. Now, let's talk about combining like terms. In order to add or subtract terms, they must have the exact same variables. Okay? Now, when I say exact same, they must have the exact same variable and exponent. We're not going to deal too much with exponents this year, but you will deal with them a little bit. So you're going to have 3x squared plus 4t minus 2x squared minus 2t plus 4s minus 17x. Now remember, when we're adding and subtracting, you have to have the exact same variable. Now when we're multiplying, you can multiply darn near anything. All right, but right now we're just dealing with addition and subtraction. Therefore, the variables and their exponents, therefore, must be exactly the same. They have to be exactly the same. Now keep in mind, we're not talking about the front number. That's something called the coefficient, which we'll learn in a second. I'm talking about the variables. The variables are right here. They're almost always represented by numbers, and sometimes they'll have exponents on them. Okay? These are what's called variables, and I'll get into more what a variable is later on. So you got to start from left to right. Say, hey, what has the exact same variable as this 3x squared here? Well, 4t, no, that's a different variable. That's a t. Minus 2x, that looks like we got a winner there. When you go through, circle it, or put an x around it, or square, or whatever. Look for another x squared. We don't have it. Now keep in mind that this goes with this. This minus sign goes with this number right here. That's going to tell you what operation to perform. Not this, not the one after the first one, but the one in front of the next one. So you're going to have to say 3x squared minus 2x squared, which is, in this case, you just subtract the coefficients here, and you're going to end up with 1x squared. It's that easy. Or you can just leave off the 1 if you just have the x's understood. So we're done with that guy, and we're done with that guy. Then you got to ask yourself, well, I got a positive 4t. What can I combine that with? What has the exact same exponent? Or excuse me, what has the exact same variable? Well, it's going to be negative 2t. So we say, hey, what is 4t minus 2t? That's going to be a positive 2t. So we add plus 2t. Now keep in mind that we keep that a positive, not because that's positive, but because the combination of this and this, when we do our math, we just do the math with the coefficient, which is 2 and 4 here. 2 or 4 minus 2 is 2, a positive 2, and we keep the t. So we're done with that guy, and we're done with that guy. That leaves us with positive 4s minus 17x. I cannot combine 4s with anything because there's not a same variable here at all. Nowhere. So I would just say plus 4s minus 17x. Well, why can't I combine that with x, 3x squared, and 2x squared? Because you don't have an exponent. The exponents have to be exactly the same too for you to add them up as well. So we can't combine that with anything. We say net minus 17x. Okay. Now let's get into some terms here. If you look at this problem right here, you're going to see that you can't combine anything because you don't have the same exponents. Now luckily we're not going to be combining like terms a whole lot, but we will be doing that, so you need to know how to do it. What I need to make sure you understand is there are some terms you need to know. There are some terms you need to know. A base. A base is anything that is risen to a power. So if I had just said plus 4 squared here also, this 4 is a base because it's being raised to a certain power. This x is a base because it's being raised to a certain power. Now that doesn't mean that's the only thing x is. X is also something called a variable, which we'll get to in just a second. But anything that is raised to a power is called a base. Okay. Now, coefficient. Actually, I'm going to talk about variable first, then I'll tell you what a coefficient is. A variable is anything represented by a letter. Okay? In this case, it's going to be x. In this case, it's going to be y. In this case, it's going to be p. This is some unknown number that we don't know as of yet. Later on, when we do algebraic expressions and equations, you'll learn more about what a variable is. But for right now, it's almost always represented as a letter. In this case, x, y, and p. And it is part of what we're going to learn in just a second, a term. And I'll talk to you about that in just a second. But this is a variable. Okay? So I'll draw little lines here. These are variables, almost always represented by letters. In this class, they'll always be represented by letters. Now, the coefficient is what is multiplied, simply what is multiplied by that variable. In this case, it's going to be 2. I'll draw an arrow up here. In this case, it's going to be 7. This doesn't have a coefficient. This is just by itself. In this case, it's going to be 4. This is not a coefficient because it's just raised to the second power. Okay? Now, a term, that is this whole thing. Every part that is added here. That is this whole thing. And the sign goes with it. This whole thing. This whole thing. And this whole thing. These are all terms. A number can simply be a term by itself. 4, 12, minus 8, so on and so forth. Keep in mind that a term, the number, or excuse me, the sign goes with it. In this case, negative 4p. In this case, positive 4 to the squared. In this case, positive 17 or just plain old 17. That's what a term is. And I'll just draw one here and you'll know that it goes to everything. Now, a constant is something that is by itself, a number by itself. No exponent, no variable, no nothing. It is just simply a number by itself. Plus 17, minus 21, plus 486,312. Anything like that. It does not, I repeat, does not have a variable. And finally, an exponent is simply this right here. That is the power that you're raising either some number or some letter to. Some variable, I mean. Right there. That is an exponent. Something squared simply means if I have 2 squared, that means 2 times 2. If I have 4 squared, that means 4 times 4. Not 4 times 2, but 4 times 4. If I have 3 to the 6th power, that means I've got 6 times 6 times 6 times 6 times 6 times 6. And I would multiply that on out. Remember, it does not mean, this is completely different than 3 times 6, which is 18. This is 6 times 6 times 6 times 6, 3, or, I'm sorry, forgive me. Forgive me. This is 3 times 3 times 3 times 3 times 3 times 3. I'm sorry. And this does not count as part of your bonus points if you catch one of my errors. Remember, I'm giving everybody, the first person who brings me any errors in my videos is going to get 5 points added to their quiz. And since I caught my mistake, that one doesn't count, so I'm very sorry. But there may be other ones. Remember, this is not 3 times 6. It is 3 raised to the 6th power. More to come.